with the Science Club, and we are in Saskatoon, the University of Saskatchewan, at the Canadian Light Source, which is this insane facility called a synchrotron right over here. And what we're doing is we're actually doing a science experiment using this gigantic machine. And I'm just going to try to explain to you quickly what this gigantic machine does. If any of you have really heard on like the Big Bang Theory and stuff like that, of the big particle accelerator at CERN out in Switzerland, the synchrotron here in Saskatoon is like the same thing but on a much smaller scale. So really what happens, the quick summary is, electrons are fired around this massive ring and they speed up so fast that they start giving off residual radiation. And the residual radiation can shoot out into the side experimental wells down around the circle, which you can use in order to carry out your experiments. So right now we're dealing with soft X-rays in order to observe the effects of UV radiation on zinc oxide creams, so things like sunscreens and baby creams.
UV radiation on zinc oxide creams. UV radiation on zinc oxide creams.
So right now we're getting an aerial view of our own group, the Science Club, right down there at the SGM beamline. The SGM stands for Spherical Grating Monochrometer. And so what we're working with essentially is soft X-rays that will come in and hit our samples that have been exposed to various UV light and will tell us how much of zinc is in each sample that we produce. So that's essentially what we're looking at as a group. So now we're here with Dr. Ryan Ramos at the SGM beamline. Tell us, Ryan, what does this giant machine actually do?
Well, we have our X-rays that are coming in here, and we have our samples of sunscreen. And the X-rays are attacking the sunscreen, and after we're able to see the spectrum and see what's happening to the UV radiation.
Alright, so after a sample's been exposed to this X-rays, these soft X-rays, how are you actually able to tell what is in the sunscreen in your samples?
We're able to see the changes in the energy levels of the sunscreen before and after, based on the different types of particles that we have inside.
Where do you get all this information? Where does it all show up?
Right behind us here, we have a few different computers that are able to calculate what's happening inside here and show it to us in a graphical format.
So now we're here with Dr. Edward Yan, our data analyst. Now tell me, Edward, what exactly are we looking at here?
Hi, I'm Edward. Okay, so we're just looking at the graphs and the graph on the computer to compare like what's the difference, so that it can tell us like what element is in our samples, such as zinc oxide or carbon or whatever. Yeah, that's basically what I'm doing.
So just to prove to you all that we're not joking, I'm here with Dr. Melissa G. She's going to tell us a little bit about what's right behind that door right there.
So right behind we have the CLS and the electron accelerator, and it has like these massive spinning things, and it goes around and around, and it sends lethal doses of radiation to whoever goes in to this back of concrete structure.
We're in Saskatoon, Saskatchewan at the Canadian Light Source. We're in the Integrated Science Club, and we got money to come here to do leading scientific research, work with scientists that we would have never even met in our entire lives in any other opportunity. So, follow us on Twitter, where you can link us through the Appleby homepage, and stay tuned for our results of this experiment. They're about to be really interesting, people.